Yeah, in the previous sections, we have seen that transition. Yeah, in the previous sections, we have seen that finite automata, DFA, and NDFA. Now we'll see transition diagram and transition tables. What is meant by transition diagram? Transition diagram or a state diagram is a directed graph. Why we are saying that it is a directed graph means we are having the directions from the state to from one state to another state. So here we have the one state is called the node, and moving to the another state or is called the node. We can say that it is a node or a state. We can say that node or state. Yes, right. By taking the input alphabet A or 0 or A as an input and moving to the some other state. So in the graphical representation, we can say that vertices and the edges, directed edges and the vertices we are having. The transaction that is moving from the this state, one state to second state. The transaction is represented as a delta of delta of state 1 comma A is an input gives to state 2. That means it is moving to the state 2. This is called the transition. So that transition is shown in the transition diagrams, how it is going to be moving from the one state to another state. Okay, so it is a directed graph representation. So this is a diagram we can see here, the transition diagram. Here we have the four states Q0, Q1, Q2, and Q3. Here the input alphabets are A, B, A. So we can say that input alphabets summation equal to AB. Capital Q equal to Q0, Q1, Q2, Q3. That is the transition diagram. Now we'll see the transition diagram to table. How we are going to be converting the diagram into table. So now we will draw the table here with states and input alphabets. Here, here we will write the states. Here we will write the input alphabets, either A, B, or 0 or 1. Here states Q1, Q2, Q3, Q4. And here we have the state Q0 is a starting state. So in the table we are updating Q0 and it is a starting state, so we have to keep the arrow mark. After that, we have the state Q1. Now we are going to update in the Q1 in the table. Next, Q2. We have to update Q2 in the table. Next state is Q3. We have to update the Q3 state in the table Q3, and Q3 is a final state. So it has the circle. So this is the way we are going to be representing the states in the table. Now, how it is going to be reading the alphabet from Q0 to Q1, how it is moving, what the alphabet it is going to be reading. That means here we have to place the states according to their input value. Okay. Now see here on Q0 by reading input A, it is going to the state Q1. So here we have to get the Q1, right? Here we have to get the Q1. So there is a no transition from the Q0 to B. So we are going to write the 5. Clear? Q naught on A, it is going to the state Q1. So we wrote the Q1 as an input A with the output is Q1. That is a state, current state. Here there is a no transition with B. So we wrote that as phi value. Next Q1 on B. Here we have in the input alphabet is B. There is no A for this. So here there is no state. So Q1 on B we are getting the Q1 on B we are getting the state Q2. At the place of Q1 on A we'll get the phi. Clear? Next, for the remaining states, we consider the graph or transition diagram like this: Q naught, Q1, Q2, Q3 with the alphabets A, B, A. The final, the transition tables will be looks like this. Right, we have the states Q naught, Q1, Q2, Q3. Q1 is in starting state, Q3 is a final state, so it is a circle. Here we have the Q1 on A, it's moving to the state Q1. Q1 on A, it is moving to the state Q1. There is no B transaction. Q1 on A, there is no transaction. So phi Q1 on B, it is moving to the state Q2. Now the current state is Q2. Now come to the current state Q2. Q2 on A. Q2 on A, we are moving to the state Q3. Q2 on A, moving to the state Q3. There is no transaction for the Q2 on B. So we represented as phi. Q3 is a final state and the state does not having any transitions. So we're keeping it as phi phi. Okay, this is the way we're going to be representing the transition diagram to transition table. Now we will see the how to identify the transition table is belongs to DFA or NFA. So by looking at the table, we can say that the given table is deterministic finite automata or non-deterministic finite automata. Let us see the table here. We can observe that in this table we have the states, input alphabets A and B, and the states in the output. So here all the states are single states only. So if you're having the single state, it is called the DFA. The output states will be the single means it is a DFA. Here we can observe that in the table we have, in the table we are having the two states by reading the on Q naught, by reading the input A, it is moving to the state Q naught and Q1 and Q2. So here we have the two states. The same way for the observe that in the Q1 also, Q1 on B, Q1 on B, we are moving to the state Q1 and moving to the state Q2 and Q4. That is here also we're having the two states. If we found two states in a table, set of states in a table, then we can say it as it is a NDFA or NFA. Clear? This is the way you're going to be identifying the transition table is related to DFA or NFA. Now we will see the table to diagram, transition table to transition diagram. Here we consider that NFA table. So NFA, from the NFA table, we are going to draw the transition diagram or a state diagram. So first, initially we have the Q naught is a starting state. So we have to consider the Q naught, Q1, Q2, Q3, and Q4 states. Right? Actually, we have this, but as per the first transition Q naught, we are having the Q1, Q2. So I consider the states Q naught, Q1, Q2 here. So on input A, it is moving to the states Q1 and Q2. Right before that, it is a Q1 is in starting state. So I given the arrow mark to the Q0. Now the transaction starts from Q0 to on a Q2 on a Q1. Clear? So for the B, there is a no transitions, so 5. So no need to draw any transitions in the transition diagram or the state diagram. Next, coming to the next, we are having that Q1 state. So next we are having the Q1 state. So draw the transition from Q1 on A. It's a 5, so leave it. Q1 on B. We are having the Q1 on B. Q1 on B. We are having the Q2 and Q4. So we have to draw Q1 on B, Q4 and Q2. So we have to consider the Q4 is not there. So we have to draw the Q4 state. So here we draw the Q4 state. Now and Q1 to on B, we are moving to the Q4 and Q2. So now we have to draw the transition. So Q1 on B, Q2. Here we draw on that line and Q1 to Q4. Next one is Q1 to Q4. We done that. Okay. Next transaction is Q2. So here Q2, we have to draw the Q3 here. There is a no state here. So we have to draw the Q3 state and draw the transition with the alphabet A. Right here we have the Q3. Q3 with input alphabet A. So it's clear. Here we have the input alphabet A. There is no transition for the B, so fine. Next coming to the Q3. Q3 on A, there is no transition. Q3 on B, Q4. So here we have the Q3 on 4 on B, Q4. Clear? For the Q4, Q1 on A, right? Q4 on A, we are having the Q3. That is here to here, we have to draw the line transition. And Q4 on B, we have the Q4. So we have to draw the itself, that is loop itself. Q4 to Q4 means itself. It is called the loop, itself loop. So on B itself loop. This is the drawing of transition diagram by seeing the transition table. Right? Hope that you all understand the how to draw the transition diagram and how to identify the DFA and NFA by seeing the tables, right?